Hello, everybody. Here we are going to present our finding about auto-tuning on GPUs to achieve green computing. So that is the reason that our slides in green. Why we choose to study about energy efficiency and energy consumptions in the context of GPU. One of the reasons is that in some applications, high energy consumptions is the main bottleneck, not the absolute performance, such as in a square kilometer array project, which is the largest radio telescope of the future. So in GPU programs, we have several parameters like grid size and block size, which their values can impact our energy consumptions or energy efficiency. So our main research question here is that if the power capping also can be considered as a new tunable parameters for the GPUs or not. We identify two set of tunable parameters in the context of GPUs, which is kernel parameters, something like grid size and block size and tile size, and GPU parameters. For GPU parameters, we define three different configuration search strategy and represent them with S1, S2, and S3, which in this, which here, F core, F memory, and PC represented core frequency, memory frequency, and power capping. We also define four other expression here, which is our search space size, power capping size, and power capping ratio. Which, to understand the meaning of them, I refer you to read our research proposal. We performed our experimental analysis on 5 different GPU from 3 different generations: Kepler, Maxwell, and Pascal, which in this table, you can see the characteristics of these platforms. We choose a brute force search method in our auto-tuning technique and also define 3 objective functions, which is energy consumptions, energy efficiency, and performance. We also choose 3 different benchmarks, which is the stencil, matrix multiplication, and vector add, with which in this table, you can see the overview of our benchmark. Among our 5 different GPUs, our results on Nvidia GTX 980 could provide us more interesting results. For example, we could improve the total energy consumptions for vector add, stencil, and matrix multiplications benchmark to 21, 23, and 17% in comparison to only tuning core and memory frequency, I mean the S2 strategy. We also could improve the energy efficiency for these 3 applications with a to 23, 11, and 9%. In the next 3 slides, we see the impact of power capping tuning on energy consumptions, energy efficiency, and performance. As we can see that the power capping level can influence on our objective function, and also the pattern or the relationship between the power capping level and our objective function value is also dependent to our benchmark. When we make a comparison between the S1 and S3 strategy, we see that both of them follow the same pattern. And the reason is that the search space in the S3 strategy are the subset of the search space in the S1 strategy. Our conclusion is that the S1 strategy can provide us the best results if our power capping ratio is a large number. And also GPU level power capping is a new tunable parameter in the context of GPUs, which it can boost our search space, but it can provide us a new opportunity to reduce our energy consumptions. One of the future work is doing more, performing more experimental analysis on newer GPU architecture such as Pascal and Turing.